While we've been building the engine that's actually going in the T-bucket, we've mocked up with this spare engine to try and work out some of the limitations that we might have while we're building the new engine. There's actually not a lot of room in a T-bucket to fit a large V8, especially when you make some of the choices that we have to put the steering behind the front axle. Quite a few T-buckets have this the tie rod in front of the suspension. That to me makes the car look a little bit silly, really. And if you can, tucking it behind the front axle makes for a much neater installation. What it does, however, is reduce the overall length of the engine, because it pretty much fixes how far forward you can put the radiator. When we've mocked up the radiator and put an electric fan on it, every quarter of an inch becomes important, believe it or not, because if you're not careful, if you move the engine too far back, there's no room even for different types of distributor cap, let alone an HEI distributor, which we're not planning to run anyway. And what we've also found is that the angle of inclination that you put the engine at also affects how much clearance you've got with your firewall. So what we did, we put an angle gauge on here so we could get the carburetor level. So we mock things up. And what we're now deciding is the type of distributor that we put on here to have a smaller cap as possible. And we're also making sure that we use a short water pump and keep these pulleys to an absolute minimum, so we've got maximum amount of clearance between the water pump pulley and the electric fan that we're running on the radiator. Now these are all choices that you have to make, so the more mocking up that you do and planning, the better, because it's better to do it right once rather than have to go and correct these mistakes later on. So that's just a sort of an outline of some of the things that we're finding as we go forward with this T-bucket project. As we continue the build on the 388 cubic inch Chevy engine for the T-bucket, I wanted to explain one of the problems that we found with the camshaft installation, and particularly the timing gears here. When the engine came to us, it was fitted with a cam button, which is to stop the cam moving too far forward. Unfortunately, this cam button was pushing the cam drive gear against the block, and the drive gear was wearing itself away and the block at the same time. Now, if that goes unchecked, you will end up with a situation where the lifters will start hitting the lobe on the opposing side of the cam. So the correction that you have to do is to put a thrust washer behind the cam drive gear, and also make sure that this button is properly machined to prevent the forward end float. So first of all, we remachined the drive gear and the block, and then what we did was we worked out the thickness of this special spacer that we made in the workshop, and we determined the size of that spacer by putting a straight edge between the two drive sprockets, and that told us exactly the thickness of the spacer that we needed to get these two sprockets in line. And that also put the lobe on the camshaft directly in the centre line of the lifter bore. So putting the thrust washer in there prevents the problem that we were talking about with the cam moving too far backwards. To prevent the cam moving too far forward, ideally we want a nice cast cam drive gear cover. These are much more rigid than the pressed steel ones, so there's a much less chance of flexing. They also give you a nice flat area there for this button to rest against. And what we're looking for is probably about a 5 thou clearance between the two. And the reason why I've chosen a different cam button here is I can remove this plastic button out the top, and I can machine the aluminium housing to get me exactly the right clearance. So what I've done is I've removed that. I put a piece of plasticine on the edge of the button there, and I'll then reassemble the the cover with the gasket. When I remove it, I've got a plasticine that's been squashed, and I can then use my vernier caliper to measure the amount of material that I need to remove off the button to get exactly the 5 thou clearance. So once that's all bolted up, not only have I now got a thrust washer on the back of the gear to prevent it going backwards, I've got this rubbing surface here to prevent it walking forward. And that means that I've prevented the problem with it rubbing against the block and any other issues that we had with too much preload. While I'm here, I better explain this timing marks on this crankshaft gear. This is a Cloy's adjustable sprocket. So we actually have 3 different possibilities for installing that sprocket on the crankshaft, and a corresponding alignment mark which goes with the dot on the cam gear, and you've got 3 different positions you can put it in. This is with the cam straight up, so that's 0 advance or retard. You can choose either of the other 2 keys and move the sprocket round. You can either have 4 degrees advanced or 4 degrees retarded. So you can play games with whether you want more top end revs or more bottom end torque by adjusting that. We're going to go straight up for now because we've got a nice lively cam in here. Manufacturer went to a lot of trouble to get that grind right, and we're going to see if that's good for us. But I thought while I was here I'd explain why we've gone for that type of sprocket to give us the adjustability on the way that we advance or retard the cam. I thought I'd talk to you about the lubrication system on the high performance small block Chevy we're building. It's quite important. If you don't get this right, you will destroy the engine. So if you think about it, the oil's the lifeblood of any engine really. So to uprate everything, what we do is we put a higher volume pump on. These have got taller gears. The higher volume doesn't always mean higher pressure, because the pressure is controlled by the pressure relief valve, as in the case of the pump. But what it does mean, if you're going to have a higher volume, is that you've got more headroom, if you like, for all the bearing clearances that we've got. If you go for the higher volume pump, there's a few things that you need to do. One of the things, I've got a picture here, the main cap where the pump bolts to, we basically radius the outlet port that goes through the main oil gallery, use a die grinder to polish the inside, open it up and take any sharp edges off it. If you do that, you'll reduce the pressure loss as it goes towards the oil filter. The other thing is that these pumps take a bit more drag to actually drive, so you need a nice new steel sleeved high performance drive shaft, because the oil pump is driven by the distributor. So if you don't have a steel sleeve on that, so some of them come with a plastic sleeve, this will wobble around and it could destroy the pump. So those are the first 2 things that you need to understand. The next thing is the clearance between the case of the pump that bolts to this and the main body of the pump and your gears. So if you put a straight edge across here, put a feeler gauge in between, that end clearance here needs to be about 2.5 thou. Quite often these pumps come with a bit more clearance. This one had a 3 thou clearance. So what you do is you take the gears out of the pump body, take that casing, turn it upside down on a surface plate with some emery paper or wet and dry paper, and you'll basically flat this surface off, put the gears back in and keep checking it till you get your 2.5 thou. You can go as rough as about 400 grit to start off with, but you certainly want to be finishing with 600 grit wet and dry on this. Like I say, usually you take a little bit at a time, don't overdo it. So those are the 2 important things there. Drive shaft, pump clearance, 2.5 thou. When you assemble the pump for the final time, either put some heavy oil in here or maybe even some grease, so your pump will prime much quicker if you do that. That will help, because it's, like I said, it's going to stand for quite a long time. so give it a chance. The next thing that you want to get right is the clearance between your oil pump pickup and the bottom of your sump. If you have it too close, it'll restrict the oil flow, and if you have it too far away, you'll start pulling air from the free oil surface. We're using a deep sump, performance sump, so we actually have to modify where this pickup goes. So if you're going to buy a new pump, always get a new pickup. The problem with these pickups is that they're a press fit. So what you have to do is a special tool to hammer them in. But once they're in, you can still tap it around to get the clearance. What you ideally want is between 3/8 and 1/4 of an inch of clearance between the bottom of the sump and the oil pump pickup here. What I do is I trial fit the sump with the sump gasket, put a piece of plasticine on here and keep tapping that until you get it right, get your 3/8 clearance. Then when you've done that, to stop anything leaking and moving, because these pickups can fall out, I then go and TIG weld it round. You can get high performance pickups, but you have to go through the same process of setting that pickup to sump clearance. And the performance pickups usually come with a little tab to bolt it to the pump bolts instead of having to weld it in. But whatever you do, getting that clearance between the pickup and the sump is critical, and also making sure the pickup doesn't fall out or move when you've done, by either welding it or using a high performance pump that bolts to it. Some people recommend brazing there. If you do that, you're going to put a lot of heat into it. But whatever you do, take your pressure relief valve out. Springs don't like getting too hot, so if you put a lot of heat into it, you need to take that out, else you'll weaken your spring. Put it all back when you've done, and then put this on a flat plate and make sure it hasn't warped. Just make sure you stone it flat. Then we're good to go. When you've done all that, you can bolt that up. You're going to have more oil flow, you're not going to have any leaks, and it's all going to be blueprinted and ready for a performance lubrication system. So just in summary, the important things are use a high volume oil pump, modify the cap by reducing any pressure losses by radiusing the oil gallery as it goes to the oil filter. Use a brand new drive shaft with a steel sleeve, high performance version if you want, by either from ARP or from Moroso. Make sure you blueprint the pump by setting the gear clearance to the top cover to 2.5 thou. Also set the distance between the pickup and the sump to between 3/8 and 1/4 of an inch. When you've got it where you want it, either tack weld it in, or at least use sealant around here. When you put heat on the cover to do that, take the pressure relief valve out and the piston and the spring, because they don't like a lot of heat. And when you've done all that, double check that clearance again by trial fitting the sump, and then you're good to go.